Imagine legally stealing the examiner's mark scheme right out of their hands before you even sit down for your Cambridge IGCSE Physics 0625 exam. Well, welcome to this explainer because today we are orchestrating a literal mark scheme heist. We're going to break down the exact strategies, the common traps, and the precise command word frameworks you need to secure absolute maximum marks for energy resources, electricity generation, and Sankey diagrams. No fluff, no generic study tips, just pure, targeted exam strategy. All right, let's get right into it.
Okay, look closely at this exam scenario. It's a Sankey diagram calculation and a practical investigation of energy resources. The student wrote, energy is lost and the efficiency is 0.75 joules. Can you spot the fatal flaw that's losing this learner massive marks? You've got 3 seconds. Go. Time's up. So, the mistake here is incredibly common, but man, is it devastating to your grade. They used the word lost instead of actually specifying where the energy went. And worse, they assigned a unit, joules, to efficiency. Efficiency is a ratio. It has absolutely no units. It's a really painful mistake, but examiners see it every single year.
And honestly, this brilliantly illustrates exactly why ordinary revision completely fails. Let's look at a quick two-student duel to see what I mean. On the left, check out the flawed answer. The energy goes away, the current changes. It's vague, it's got the wrong variables, and there are absolutely no units. But look over on the right. The top-hand answer says, thermal energy is dissipated to the surroundings. The current of 2.5 amps is measured using an ammeter in series. Do you see the difference? What makes this top-hand answer so incredibly powerful is the precision. It uses correct physics terminology, it pulls exact data evidence straight from the source, and uses strictly correct units. If you're just memorizing textbook facts without learning this very specific language, they're leaving serious marks on the table.
Now, to pull off this heist, we need a map. Check out this extract directly from the Cambridge syllabus. We're looking specifically at sections 4.5 through 4.8. This right here is the exact territory where examiner questions on energy for electricity and energy resources are drawn from. When they ask you to evaluate an electricity generation method or, calculate efficiency using a Sankey diagram, it is coming straight out of this forces and energy block. You absolutely must know these specific subtopics inside out.
Now listen up, because you are about 4 minutes away from a massive breakthrough. In just a moment, I'm going to show you the exact examiner clue that changes a Sankey diagram answer completely. It's this wild trick that turns a seemingly impossible multi-step calculation into a super simple checklist. But here's the catch. If you try to use that clue without the proper foundation, it is going to backfire. So first, you need the master framework that makes this examiner clue blindingly obvious. Let's see how this builds.
All right, here is your skeleton key. This is the 4-step framework you absolutely need to build top-band answers and lock in those maximum marks for any explain, describe, or evaluate question type in the 0625 syllabus. Step 1. Concept. You just state the key definition, law, or equation using the correct physics terminology. Step 2. Evidence and data. Pull specific numbers, graph trends, or apparatus features straight from the provided source data. Step 3. Scientific reasoning. This is where you logically connect your concept directly to your data. And finally, step 4, examiner wording. Basically, command word fulfillment. Did they ask you to describe or did they ask you to explain? We have to use exam-safe wording to match exactly what the mark scheme is demanding.
Let's actually apply this framework to a standard Cambridge-style electricity generation question. Say you have a source page showing a generator circuit. Step 1, you state the concept, electromagnetic induction. Step 2, you cite the evidence. You identify the correct component symbols, the current paths, or say the specific meter placement shown in the diagram. Step 3, scientific reasoning. You explain exactly how the field patterns interact to induce an electromotive force. And step 4, examiner wording. You substitute your values into the correct equations and make sure you've stated the energy transfers accurately, rather than just vaguely saying power is made. The whole point here is that you're building an airtight case that the examiner literally cannot deduct marks from.
But even with the best framework, students still fall into traps. So let's systematically break down the absolute classic errors. On one side, we have the most common traps: missing units, rounding too early in a multi-step calculation, giving vague explanations like making it better instead of actually offering strong practical improvements, graph axis errors, and drawing conclusions that simply aren't supported by the data. But don't worry, on the other side are your immediate top-band fixes. Always use strict units. Keep full significant figures in your calculator until the very final step. Specify your variables clearly, independent versus dependent, and meticulously check your graph scales. Take a mental screenshot of this because it's pure gold for your revision.
Okay, let's escalate the stakes a bit. It's time for an interactive challenge.
I want you to spot the error in this data analysis. Imagine an exam question asks you to design a practical investigation comparing the energy output of two different miniature wind turbines. A student writes, "I will spin the turbines and measure the voltage. Then I will say which one is better. I will repeat the experiment." Take a second. Write down your own answer checkpoint in your head. What is completely missing from this practical investigation designed based on those strict physics standards we just went over? All right, let's see how you did with some instant examiner-style feedback. If you just thought, oh, they need to measure current too, well, you get 1 mark, but you completely missed the top band. The real issue here is command word fulfillment. To secure all the method marks for a practical investigation, you have to state your independent variable, which here is the type of turbine. You must state your dependent variable, which requires both voltage and current to calculate electrical power. You've got to list your control variables like wind speed and distance from the fan. And finally, you can't just say which one is better. You have to state exactly how the data will be used to reach a scientifically valid conclusion. Again, it's all about precision.
And to guarantee that precision, I need you to memorize this final checklist. Every student has to run through this before submitting their final answer on a practical data question for energy resources and Sankey diagrams. Units, are they present and correct? Significant figures, does your answer match the lowest number of sig figs given in the source data? Graph scale, does your data cover more than half the page? Uncertainty and safety, did you mention a relevant safety point, like say, keeping water away from electrical generators? And finally, reasonableness. Look, if your calculated efficiency for a power station is 150%, you know you've made a math error. Energy out can literally never be greater than energy in.
So, congratulations, you've secured the master framework, you know exactly how to leverage source pages, and you've survived the Sankey trap. You have successfully heisted the mark scheme for this topic. But what about the others? While you've mastered energy and electricity generation today, the 0625 syllabus is packed with other question-type traps that examiners specifically use to filter out top-tier students from the rest of the pack. There's a whole different set of pitfalls just waiting for you in thermal physics and mechanics.
And you can't stop halfway through the heist. Your escape tunnel out of these traps is waiting. Watching our next explainer on Physics 0625, Common Traps by Question Type, is absolutely mandatory if you want to completely bulletproof your grade. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. Because if you can master energy resources today, what's stopping you from completely dominating thermal physics tomorrow?